connectors and cables, everything consumable. Okay. And okay, it will be still flexible or elastic till 9%, but it is not recommended to go even greater than 0.2 to be efficient. Fiber can break at lower tension with cracks. What makes the cracks? The microwave. When the fiber compressed, it will be cracked, and you cannot see it physically. When longitudinal tensile or transverse force are applied to optical fiber, it can cause little surface. Longitudinal, when you apply tension force. Transverse means it's perpendicular to the fiber when it is compressed. This potential weak force can develop into micro cracks, which may cause breakage of the fiber when it is later subjected to increased tension. Optical fiber have some elasticity, stretching under right loads before returning to their original length when the load is low. So when you stretch fiber optic cable, it will go back to its original length. But if the tensile force is not exceeding 100, so be careful when you are pulling the cable. Be careful not to apply higher force, because the higher force may cause tensile force more than the cable can withstand, and when you finish, the cable will not go back to its original length or normal conditions. It will deform. As we said, maximum 9%. After 9%, it will break. However, as we said, it is advisable to limit virulent strain to less than 0.2%. This limitation will avoid development of financial loss. Heavy tension could break the fiber in a cable if stretched more than 5 meters. If you remember the second features of the cable construction is to facilitate the handling, correct? Many fibers in one cable. So the construction allows us to have many fibers in just one cable. Also, mounting and support structure. Around the fiber itself, which is the glass tube, there is some other layers that strengthen and protect the fiber from the external environment. Also, protection against environmental hazards. We have also water blockage layer to stop water filtration. Also, we have OH ion filtration. OH ion can penetrate the jacket of the cable and reach the glass itself. There is a layer that block and prevent, stop the OH ions. OH ions can happen or can release in the atmosphere because of the decomposition of some material like plastic, all batteries. Sometimes this can release OH ions. OH ions has the power to penetrate objects, so it can penetrate the cable. There is a layer to stop this OH ion to penetrate the cable. Here it says that the hydrogen diffusion from air, the composition of plastic sheets and batteries can release OH ion. OH ion. The name of H ion is the hydroxide ion. As we said, we always prefer to have the whole cable construction dielectric. Dielectric means non-conductive. Non-conductive material. Why? Because all dielectric cables do not contain any metallic components. And what will happen when there is no metallic component? No requirement for grounding, no potential for explosion, no potential for fire, no potential for electric shock. Yes. No potential for crosstalk or interference. Yes. EMR. Such non-conducting cables are inherently safe for use in hazardous situations. where the presence of explosive gas, smoke, metallic cables unsafe. You said that you most of you are working on fire alarm. Fire alarm. Which cables are you normally used for fire alarm circuit?
Copper cable. 120.
It is fire rated cable. FB200, FB200, FB200. You are not using MICC?
Open cabling,
It's open.
open area.
Open areas.
But in the conduit we are using is the FOC.
What FB200? Let's use FB200. And in GI point.
Yes.
But in open areas you are using the MICC. What is the most common problem you are facing with MICC?
Installation, isolation,
Termination.
this is current this one.
And the solution is powder.
Yes. Some heat is packing.
Correct. The solution problem with MICC. Which category is the fire alarm cable? Category 1, 2, or 3? Category 3. All the electric cables are not affected by any form of electromagnetic fields, and therefore immune to lightning and high voltage with respect to S. يعني suitable for use in high voltage areas or areas where you are expecting lightning, because it will not conduct. As we said, we are resistant to electromagnetic interference. Okay, what are the cable structure elements? Central member, thread members, fiber housing, moisture barrier to stop moisture to spread inside the cable, shield, protective armor. All layers are. These are cross section area and a fiber optic cable. This is the central member. This is the 5 threads member. This is inner sheath. This is steel armor. This is armor cable, by the way. And this is the outer sheath. This is the fiber housing. This is the fiber itself coated by a layer. And this is, if you remember, the water barrier. See this thing? This is a water barrier. Absorb the water and block it to propagate further to the fiber itself. This is the component of armor fiber optic cable. After all, inshallah, he will bring pieces of multi-volt and single-volt. Connectors, pigtail, match cord, match panel. Inshallah, you will see this. Now we did that central member. So what is central member? Central member usually made of fiberglass. Fiberglass. Why? To provide rigidity. Why the cable must provided with why fiber optic cable must provided with central member? Central member helps prevent microbend. When the cable is subjected to compression force, the central member will take the shock and will protect the fiber itself from the microbend. Also, it is added tensile strength to the cable. This is the central. The central member contributes to the tensile strength of the cable. The fiber optic optic cables need support, correct? So they are laid around the center member. So center member like a support, supporting all fiber cable around it. So we go back here. These are the fiber tubes, eh? Like supporter to this tubes.
Very hard.
Very hard, yes, correct, very hard. Normally fiberglass or hard material, rigid material.
What something is correct.
Yes, correct, correct. The central member contributes to the tensile strength of the cable. Many fibers are built around the central member by which they are supported. It is usually made of fiberglass and possibly incorporating steel to be hard and rigid. Sometimes it's provided with not only fiberglass plus steel to be rigid. It provides rigidity, thus preventing the fiber from being bent too sharply. Yes? When you have the center member in the center, if there is a bend, this center member will resist the bend, and hence avoid the sharp bending that will cause macro bending. And even sometimes extend to macro bend, because it will start with macro, and if it is maintained for longer time, it will change from macro to micro. So the strength, the central member, because it's rigid, it resists the overbending of to the cables, and then reduce the chance of macro and micro. For indoor installation, because the mechanical stresses is unlikely, it might be without central member. Not all fiber optic cables provided with central member. Some cables that are intended to be used indoor, and there is no any chance of mechanical stresses, so why not? We will reduce the cost. Because the cable with central member is high cost, and it's more costly than the cable without central member. So if we know that the cable will be installed in such location where mechanical stresses are unlikely, so better to order cable without stress, without central member. But this, of course, only indoor application. Then we have the metallic strength member. This one, this cable. Yes. It provides good rigidity, low temperature performance, and what's the disadvantage? Weight. It adds extra weight to the cable, so harder to handle. Heavier strength member. Sometimes you can ask the manufacturer to fabricate the metallic strength member from dielectric material, non-metallic, but you have to be more in this case. The weight will be less, and the handling is better. Zero chance of electrocution, zero chance of EMI and RFI, but you have to pay more. So, you know, my colleagues, normally, not only in fiber optic cables, in all engineering aspects, at the end of the day, the decision maker think about cost. So, technical people like us, we understand and appreciate the technical aspects. But the decision makers, in many cases, the top managers, they always think about money, how much I have to pay. So if you tell him, okay, better to have it dielectric material to avoid EMI and to avoid crosstalk and this thing, then he will be ask you, how this will affect? What's the problem? If there is some distortion on the signal, and what is the chance of fire to happen? You might say very rare chance. You will say no problem. Go for the metallic one, because you will find maybe this like 1.6 3 times the cost of the metallic one. So I know that the decision maker people, they are much concerned about cost. You will ask you what is the price for this and for that. Automatically you will ask this question. So the disadvantage, cost will be correct because it is a non-metallic. Fiberglass and sometimes reinforced plastic, but still non-metallic because the reinforced plastic is non-metallic. It will still maintain greater density, yes, but with higher price. The reinforced plastic material has the strength of steel, and this is the advantage. But it is non-metallic. So you are getting the advantage of steel, but still you are not using metallic component, and this is the point. That's why it's costly, because the manufacturer will give you the properties of steel with non-steel. So that's why it's costly. Yes. And because it is not metallic, it will not corrode, and it will not decay, and it will not be twisted easily, it's rigid. But don't forget that you have to pay. You have to pay more. So it depends. Fiber housing. Fiber housing. This one. This is enclosing, encapsulating the fiber tubes. The fiber tubes. The fiber housing, we have the loose buffer and the tight buffer. Loose buffer usually is a loose buffer or slotted core construction, and mostly used for outdoor application, where fiber are likely to be subjected to external forces. That's why you have to have the fiber loose. If it is tight, any external force will affect more. But if it is loose, so we'll have a space for the fiber to move through. Yes. So for outdoor installation, we use the fiber optic cables from the loose buffer type. Yes. For outdoor application, where fiber are likely to be subjected to external forces or extreme temperature change. Loose buffer construction used in aerial cables, duct cables, direct current cables. They are all loose buffer. You can see here that it's a loose buffer. See, loose. It's not tight. There is some space around that you are the fiber. So here this is longitudinal rib cord. You know what is the function of this rib cord? Have you said before?
Yes, the same like rope.
Correct. Enable you to cut the jacket back by just pulling back. Yes, correct. This is called rib cord. Then you remember the water blockage tape I told you? This is the water. If there is any penetration, it will stop, block the water to this state. It will not continue further to the fiber. Outer stress member. Stress member. This outer stress member, and this is outer current. And what is MTBE? MTBE stands for what? High, MTBE, medium, polyethylene. Medium density polyethylene.
Medium density polyethylene.
You can find the jacket sometimes made of high density of polyethylene and sometimes medium density polyethylene. Different types of thermoplastic.
Medium density
This is the purpose of
polyethylene.
ripcord, as our colleague said. The purpose of a ripcord is to cut back the jacket to expose the wires of the cable, so you don't run the risk of cutting any of the wires. You pull the cord, it cuts the jacket. This helps make splicing cables easier during installation. You don't need to use any cutting tools. You can use this ripcord. The loose tube construction make use of hard, smooth, flexible tube whose inner dimensions are much greater than the fiber. You remember? Here again, see. The inner diameter of the tube is greater than the combined diameter of the so that's why it's called loose. One or more fiber can be installed in a loose helical fashion inside, so they can move freely inside the tube. The tube isolates the fiber from external force. So if we go back here, so this tube, this is the fiber. This is the fiber. It's a tube. The tube protects the fiber from any external force. Okay? And as you can see, it is loose. There is a space between the tube and the fiber. Again, this is the loose tube. There is other design which you call slotted core cables. This is the slotted core cable. It is in the form of slots, yes? Like slots. This is the central strength. Remember? This is the tubes, fiber, cell, contained in a slots. So this is called slotted core cables. Have you seen this one before? Or only you are dealing with the loose power one? Loose power one. This is the central strength member. This is the optical fiber itself. And the measure, here is the measure blocking. This is slotted core. This is the cable sheath. And this is the core.
So this one.
We have seen the loose buffer. Now we have the tight. Tightly buffered fiber are encased in a slot in a soft plastic which reduce the forces applied to the fiber, and then have a further external buffer or the plastic rising external. With the tight buffer to provide physical protection. In this case, the total buffer will increase the diameter and provide protection against micro. Because in this case you have two buffers. The tight one plus additional one. So what are the advantage of tight buffer? Direct alignment to connectors. Yes? No patching required. Run directly to the equipment. It's tight and straight. Greater crash and impact resistance than loose buffer cable. Used in risers. Supports longitudinal stresses. Physically smaller than loose tube. Because we reduce the spaces. So the be distributed to different devices without the use of patch panel. Even though it is not practical, but it can be. Now, what are the disadvantages? It tends to introduce some micro-bending losses and lower isolation of the fiber from stress. Generally, this is not a problem. Another construction, what's called ribbon construction. Have you used before the ribbon construction? It's not commonly used. It's like a ribbon here. A group of coated fibers is arranged in parallel and then encapsulated in plastic to form a multi-fiber ribbon cable. These are fibers, side by side, encapsulated in this ribbon. Okay. Not commonly used. In this case, individual ribbon may contain 5 to 12 fibers. You can use multiple ribbons. This is one ribbon only. This one ribbon contains 1, 2, 3, 4, 5, 6, 7. One ribbon. You can have 5, 6, 8 ribbons. So, for example, if you have 10 ribbons times 6 or 7, so 75 in one. Okay. What are the advantages of ribbon construction? Very high density fiber. Yes, it can hold many fibers to high density. Right. And it's effective splicing techniques for connecting fiber ribbons in a single splice. So there is some special splices to connect the ribbon cables together. So it's one shot, one-time job. You can splice all together. Okay. Also, multi-fiber connectors for jointing ribbons. So what are the disadvantages? Individual fibers can have an even strain. Yes, if there is mechanical force, the effect of the impact of the mechanical force will not be eventually distributed to the fiber. Yes, the outside fibers will be subject to higher stresses. For example, if there is a compression force here or here, this one and this one will withstand higher compression than this one. Correct? So if there is a mechanical force, it will not be distributed equally to fiber. This is a problem with the advantage with ribbon. This is a construction of ribbon. See, here we have more than one ribbon. 1, 2, 3, 4, 5. 5 together, right? This is again, this is the outer jacket, medium density polyethylene. This is a water barrier, blocking barrier for moisture. This is a ripcord again. This is the fiber ribbon. And this is a buffer tube. The moisture barrier is extremely important for external and submarine cables. Note that water permeate through plastic. Common barriers include lamination of polyethylene and aluminum foil, petroleum jelly, or silicone rubber. These all are different kinds of water barriers. Can be anything. It can be aluminum, laminates like strips, very thin layers. Yes, it could be polyethylene, aluminum foil, as we said, jelly, silicone. Yes, silicone rubber. Yes. And it must be non-reactive. If it is reactive, it can corrode the internal component. So the moisture barrier layer must be non-reactive. If it is reactive, it will react with the internal component, and this will cause corrosion or wear and tear to the internal component. So it must be non-reactive with internal metal and fiber. Helps to cushion external forces. cable shield. You have that we have sheaths in power cables. Also, we have sheaths in fiber optic cables. The sheaths in general might be metal or non-metal. The metal sheaths might be cover tape, cover wire, this is power cable, cover tape, cover wire, or combination of tape and wire. This is metal sheath. The non-metal sheath can be polyvinyl PVC, can be high density polyethylene, can be medium density polyethylene, plastic. So normally sheath doesn't always mean metallic. We have also non-metallic sheath. Okay. The cable sheaths provide primary protection against excessive bending, and it's made normally from polyurethane for most of fiber optic cable. Also, it protects against abrasion and against cutting, against fractures. What are the material used in sheath manufacturing? PVC, if it is non-metallic, and normally it is non-metallic, it's fiber optic. All outdoor cables must be sheathed because they are likely to receive mechanical stresses. So all outdoor cables, all fiber optic cables intended for outdoor installation must be sheathed. What is the sheath material? It could be polyethylene, nylon, Teflon, special material for areas requires flame retardant. Okay, because you are working on fire alarm circuits, you have to read this. Is there a difference between fire resistant and fire retardant material, or they are just two terms for the same thing? Fire resistance and fire retardant. Think about it. I think you have seen this before. Sometimes it's written in the sheet, the cable fire retardant. Sometimes it's called fire resistant. Even the specification given by the consultant. Sometimes the consultant says, no, I need fire resistant. Sometimes he says, I need fire retardant. No idea. Fire resistance cables like MICC or FB200 or FB400, this material can work under fire conditions. It will resist a fire. For example, the MICC cable can work for 2 hours, 2 continuous hours, while it is catching fire. You can put it inside fire, totally in fire, and it will start, and it will continue to perform with no problem. This is fire resistance cable, cables that can work under fire conditions. And it can perform well, even when it catches fire. This is very important for fire alarm circuit, because if there is a fire, we need the, what if there is a fire and the fire circuit burned and lose its function? Will not be receive any warning, correct? We need this cable to last as long as possible for people to evacuate the place and for the emergency situation to be managed. But what if this cable is normal cable? So what will happen? The fire will be there and there is no warning, there is no alarm. We need the fire cable, even if there is a fire, still working, giving alarm so that people be aware and, for example, evacuate to go to the assembly place. So fire resistance cables that can function, fully functioning, even when they are catching fire. But fire retardant cable is lower category than any possible damage to the fiber itself. Then the cable armor. As I said, it is not a must for all cables to be armed. It is depending on the application and the expected conditions. If we are expecting the cable to run within an area where the external mechanical stresses is unlikely, better to be non-armed. Less cost, easier handling. Yes, less weight, yes. So it's less cost, easier to lay and handle. But what if we are expecting the cable to be exposed to some external forces or stresses? Cable armoring normally use steel wire. Under the outer sheet will be normally medium density polyethylene plastic, and immediately below this PVC medium density polyethylene layer, there is some steel wires. This is a cable. And all cables that will be directly buried shall be armed. We cannot use an armored cable for direct buried. Also, for undersea application, submarine must be armed. Why? Because there is a mechanical forces due to the wave, the tidal, and might be attacked by fish, some type of fishes or animals. So all submarine cables and direct buried cables must be armed. Classes of cables: aerial, use a steel messenger wire for internal stressing member, require extra protection for wind, because it's open area, wind loading, ice loading sometimes, yes, temperature variations, moisture ingress, ultra violet radiation. For short span dielectric cable, we can use the slotted cables, even though it's not commonly used, but in some countries, some applications, they are recommending the slotted cable for short span. Normally within 150 meters, very short span. But for long span, up to 1,000 meter, it can also be used, but with additional protection layers. For underground cables are usually pulled into ducts or buried directly, with the cable being placed in a deep, narrow trench, which is backfilled or else blocked. And it's installed in conduits or direct pipe. With underground cables, normally we use the loose tube, loose buffer. You remember? Always closed. And there is a metallic barrier for moisture. Okay, what are the advantages of underground laying? Most effective method. Greater environmental protection, because it is totally hidden and not subjected to environmental, and it's more secure because it is not accessible. No one will come and dig access the cable. Right. What about the disadvantage of underground cables? Earthwork. Sometimes the contractors, they may damage the cable while they are doing some other work. Yes. Farming, especially in areas where it is where the farming is likely to happen. Some areas, some countries, there is areas only farming. With farming, sometimes the farmers using even hand tools or sometimes some machines to arrange the arm. So in this case, it is not recommended to use underground cable, or if it is used, it must be properly protected by ties or trenches or so. flooding, also in areas where flood is big. Rodents, of course. This can be overcome with the use of steel type armor or steel plate or some form of plastic ducting or Teflon sheet metal. Metallic moisture barrier cable. Remember again, this is the central member. This is the fiber itself. A loose tube. The polyethylene sheath. Remember, the medium density polyethylene outer. If the cable is armored, we will find some steel wire armors here. Just below, just under the polyethylene outer sheath correct. This is a jelly filling here to block the water penetration to the fiber. This layer is a polymer coated aluminum foil, also acts as water blocking. So if the water penetrate and go beyond this layer, it will be blocked by the jelly filling. So 2 layers of water blocking. The first one is aluminum foil. If it's exceed to penetrate the aluminum foil, it will be blocked by the jelly filling. For sub-aqueous cables, sub-aqueous cables are outdoor cables designed for continuous immersion in water. It's permanently 24/7 in water. Of course, this cable must have special construction to avoid, to resist the continuous existence in water. This includes cabling along or across rivers, cables that are crossing rivers, or along rivers, or lakes, or channels, where alternatives are not cost effective. These cables is a preferred option for direct current in areas subject to flooding or with high water content. These cables can be used in place of direct current cable in areas with high water table. Cost-effective use dependent on situation, normally expensive, but it can be used, as we said, in rivers, lakes, channels, etc. This is a construction of subaqueous cables. Again, this is a steel member. Yes, this is moisture barrier sheath. Remember, steel armor wire immediately below the polyethylene sheath. This is the fiber itself, jelly filling tube, buffer tube. This is a picture of people are laying subaqueous cable. Most sophisticated subaqueous cables are used for deep ocean communication by international telecommunication carriers overseas. Indoor cables, physical properties dictated by fire codes. Of course, for indoor cables, it must be fire rated. Yes. So yeah, as sometimes you have to check the fire defense, the civil defense requirement. They are accepting FB200, I'm sure. Material used not in the spread of fire. Remember, it must be fire retardant at least. If not fire resistance, at least fire retardant. And also it must avoid releasing poisonous gases. General use tight buffered cable, patch cord for continuous flexible application. Aligned layers provide tensile strength and flexibility. some material are added to the layer of the cable to be fire retardant, like present here, carbonyl or carbon atoms linked with single bond nitrogen to stop the fire propagation through the cable. It's some type of synthetic high performance fibers. Batch code. What is the difference between batch code and batch panel? Yeah, yes. Yes, one of them is short, one is longer, one is with two connectors both sides, and the other one is with just one connector. And the other side will be spliced normally to the cable. Batch code designed for repeated handling and batch panel. These use internal armored fiber layers to provide tensile strength while allowing considerable flexibility. This is a construction of batch code. Here this is the coating. This is the fiber itself. Coating, symbiotic buffer. This is the armored. This is the armored stress member. The stress member. Armored means is coated by some substance from nitrogen and hydrogen to slow down the propagation of fire if there is a fire. And this is the PVC. Armored fibers are a class of heat resistant and strong sensitive fibers. They are used in aerospace application, military application. Distribution cables. Cables with tightly buffered fiber for running directly to equipment. We have the riser cables. The riser cables are normally tight buffered fibers used for vertical runs, like between floors, from floor to floor. Yes, it's cable riser. Also, we have plenum cables. Plenum cables are used in air return paths for air conditioning systems, for example, above ceiling, under raised flooring, and they must meet the fire safety. This is the construction of distribution cables.